Hello, welcome everybody. I hope this is working. It is my first attempt at streaming something to Twitch or essentially to the worldwide net. My name is Jacob and I'm a software developer by day and some sort of tinkerer and nerd by night. I love retro computing and stuff like that. But I've decided to go online and share my different hobby projects or projects, side projects, however you might want to call them, with you while I am doing them. So I've decided to just go ahead and do this. I hope that you can see me, you can see the screen. Okay, let's get started. What are we going to do here? What are we going to do in the next weeks? I've decided to build myself some sort of, you could call it stream deck. Essentially, I want to build something like a stream deck, like this thing from Elgato, where you have different possibilities of shortcuts to be called, to click on them, and to issue certain actions there. I actually have a stream deck from Elgato, but I want something more customizable for myself, and I've decided to create something with, maybe I have in mind, like maybe have some rotary encoders and big knobs at the left and the right side of that thing, so I can do a lot of other stuff with it as well. The next streams will most likely be essentially the creation of this thing, and we will see how that actually goes. I've just seen that I might be a little bit loud, as nobody is in the Twitch chat actually currently, so nobody is listening to this live. I'm not sure about this, so I hope that I've just reduced the loudness of the microphone a little bit, and I hope this is now better and you can understand me well. Essentially, it's the first stream. I will see it later on in the recording. So, okay, what are we going to do here now? We have an SPI display here, which is actually will actually only be connected later on to the system via, I think we have got 4 data pins. We will most likely have a cable select one. We have power. And we might have, let me take a look, a reset pin maybe. We have to check this. This is actually a 3-inch, I guess it's a 3-inch, 3.5. It's a 3.5-inch SPI display I just bought from AliExpress. It has a touchscreen layer on top, so we will be able to register touches, which we will need to actually build our kind of stream deck here. And we have an ESP32 controller here, nothing special. It's just the usual Room 32. So we might exchange this in the future with one which has PS RAM, because I think it would be a nice thing to have kind of double buffering for rendering this thing, especially if we have icons on it and stuff like that, so that we can flip between different states easily. So, and we have 2 breadboards here, which I've already laid out there in order to get started with this thing. I guess what we will be doing today is we will simply be attaching this thing to the breadboard. We will ensure that both the ESP and the display have power, and then we will set up our environment, which actually will be platform I/O setup, which I usually use for ESP32 and ESP development or embedded development in general. We will be using VS Code, and yeah, we will set up all this. We will take a look at different libraries to interact with the display, and then hopefully, if everything works out, we will be just displaying some pictures on this display this evening. So yeah, let's take a look and let's get started with this. First of all, we need to check out which library we want to use for this. And I actually, is this, no, it's not, it's kind of cut off, but yeah, not a real, not a real problem there, but yeah, maybe this is better. So in order to see if there are special pins we need to connect or stuff like that. So let's just Google SPI display, not Raspberry Pi, no, ESP32. So let's check. I actually know a library which I've used before. I think this one was it, which worked quite well and had integration and capabilities for the touchscreen as well. So let's check this one out. DMR cannot be used. Raspberry Pi Pico. I think, yeah, it was this one. I actually remember this example. So this should work well. Let me just check what kind of chip we have on here, because I'm not 100% sure which controller chip is on here. So we can't even see that actually. Unfortunately, I can only see that there is the touch controller is the XPT 12068 but the display controller is beneath the display actually. Okay, that's not so good. Let me just check my AliExpress orders quickly. Maybe I can find out what chip it was, but I'm quite sure it will work. I guess it's an ILI 9488, most likely. I'm aware that you can see what I'm typing here actually at the moment, because I'm on another screen here. Let me just quickly check this. Yeah, I have to log in there. So yeah, let me log in. There we will go, and I need my last orders. No, it won't be the last, but the it will be in here somewhere. So yeah, where could I have this? There is a 3.5 inch display. That's most likely it. So yeah, it is. Is there any specification about the chip that is actually used there? We have 320 by 480 resolution. That's kind of nice. So we have double the. We have quite a high resolution there. But I need some information about the chip which is used. So let me try and get this over here. So maybe. So you can see as well what I'm doing there, but that is not the is it the one? It seems, there it is. It's an ILI 9341. Okay, so we have 320 by 480 and we have an ILI 9341. Okay, so let's get back to this here and ILI 9341. So we have actually support for this, which is kind of nice. So yeah, and this library, as I expected, has the touch controller support as well. So we can use this then as well. So that's a great thing. We have this TFT ESPI library, and I guess it will just be, as most of them, configurable. Let's just take a quick look at some sort of example here. I don't really care which one, so we will instantiate it, most likely giving it certain pin mappings. So where is it actually set up? There it is set up. TFT init. Okay, where is it defined? Invoke custom library. Okay, now I'm kind of confused because where the hell do we configure the pins there? Okay, is there some sort of documentation for this thing? User setups. Okay, so we had this ILI 9341. I already forgot again. Do we have here ILI 9341? Setup ILI 9. Can we actually, they are doing some sort of pin setup here. Ah, okay, I see. Most likely we will be setting this up by defines. Will we? README? No. That's kind of interesting. Is there any... If you load a new, it will override setups kept in the user setup. You must make one setup is. You must make sure only one setup file is called. Okay, I guess we can simply. Oh no, I didn't want to open this one up. DMI. No. Okay, so I guess we will just wire this thing up and take a look then later on how to do it exactly. So maybe we can actually use this this one here, which we can actually maybe use these pins, but data command control pin, yeah, but there are definitely some missing because we definitely need to wire this up a little bit differently. So examples, fonts, extensions. Yeah, I guess maybe we will take a little look at some sort of generic examples here. Maybe, I don't know, something, isn't there some really simple test, like for example one which draws ellipses? It's just initialized here, hardware specific library. Essentially they are using the SPI interface. So yeah, maybe we can just do this. Okay, so we actually have, let me just quickly change the screen here. So we actually have here, what is it? It's some sort of, it's some sort of ESP32. I'm not even sure which one it actually is, but we can easily kind of find out. I guess it's a Wemos clone. It will be at least Wemos pin compatible, I guess. Wemos D1 ESP32, something like that. Pinout. Let's take a look at this one. So images. There we go. It's not a mini, I guess. It's most likely something like this one. Yeah, that sounds kind of reasonable. I only need a pinout diagram. Give me a pinout diagram. Can I not have this any bigger? So no, that's not the one I'm looking for. That's definitely not the one I'm looking for. That looks more like what I'm searching for, but okay, so one can't read this actually. I can't read this. Don't know if you can, but I can't. So this is the mini one. It is the one which has the pins in 2 rows. So I'm not 100% sure if this is... No. Should have taken a look to that before I... This, can I have this in a little bit? No, that's what I already looked at, and it wasn't big enough. So there has to be some sort of diagram for this one. It's a ESP. Okay, let's just ESP32 pinout. They are mostly the same because they are mostly all the reference implementation of the one that Espressif provides. So let's take a look at this. Maybe the development board pinouts. Okay, here this looks better. This looks like we can do something with it. So what we are actually looking for are the I/O pins which are commonly used for SPI. Essentially, we will not be forced to use them, but it's generally not a bad idea. But so what do we have here? I guess we will then be using the GPIO 1 and 3, the pins 35 and 34 here. You can't even see the what I'm actually scrolling around here all the time, the whole time. I'm so sorry. Yeah, I'm quite new to this streaming stuff. I need to I need to be more careful what I'm showing here. So actually, I guess we will be using these GPIO TX and RX thingies here. Those here, I guess, but I'm not that sure. So okay, let's first of all wire this thing up by giving the system power and stuff like that. So let's just put the ESP in here mostly, like we can. Okay, we can't have it with spacing on both sides, so that we can actually have that here. So we need to take care of one thing directly, which is if you look here, this is the 3.3 volt pin. This is the power pin. And we have on this side, we have 5 volts. Let's just take a quick look at what this display needs. It will just have VCC. I'm not 100% sure. Let me check here with what I've actually ordered there. Is there any information? Okay, it will actually take 3.3 or 5 volts. So we are good on both sides here, I guess. So this is not a problem. So then let's, I guess it's simpler to just take this 3.3 volt here then. Okay, so let's do this by just putting directly grabbing this one, because we will be powering up this thing by USB later on. We will be powering it by USB, which will be used for programming it and stuff like that. So let's do this here. And the problem is with this, I need to put this cable underneath before I put this one in. This row here, not sure if you can see it. There is another row which I can attach all the data wires to, but if I need some sort of connection to one of those pins here, I can't get it later on. So I'm just sticking a cable in there and putting this thing in here. So this here will be our voltage connection later on for our display. So we have to remember that. So okay, we have now put this one in. So I guess what I'm going to do is, because I can't remember all of these, I will not be able to, nah, come on, focus, damn it. The camera doesn't want to focus here. There we go. So I won't be able to remember all of these while I'm putting all these things in, and I don't want to put it all out. I will just quickly photograph this one, and I guess then I will just put that up on the screen. So yeah, I will put this display in here, which shouldn't be a big problem. There we go. So let's put it just in a way that we can actually access and connect all these pins later on. Something like this. Yeah, should be okay. Now I quickly need to get this photo. Guess I will. Yeah, I guess I will actually mirror it so that it is correct now that I've flipped the board around. So let me do this. And now we have that here. So now what have we here? We have this one, which is actually the VCC. There's the ground. Is it really? Is that? Let me just check. I'm not 100% sure now. Okay, so this one is the VCC. Yeah, okay, it's okay. It's okay, it's right. Let me put this back in here. So, yeah. Okay, so we can directly wire up the VCC connection here, which is going to be here. So yeah, actually this cable is too long. Maybe we connect it to 5 volt. Shouldn't be a problem. And this will fit better from the length of this all. So yeah, I'm not sure. I have to put this in. Yeah, just let us just use a smaller cable like this one, for example, and we go. We will be going. No, that's too small. I've all kinds of different cables here lying around, which I'm reusing for these things, and I don't want to create new ones all the time. So yeah, okay, let's just wire this thing up. We want to get something at least going this evening. So yeah, let's put it there. This will be our 3.3 volt connection. And let's put back our ESP controller. There we are. So, okay. Now we need to wire up ground. I guess we can easily do this with a... Maybe we even should do this in another way. Maybe we should wire up the power lanes here. I guess we should do that. We should wire up the power lanes and take the power from there. Yeah, that's a lot more intelligent here. So let's do it this way. So because it will be, no, it needs to go there. So do we have ground there as well? Yeah, it's but we have ground here as well, so we can take it there. That is easier. So now we are taking actually taking the 5 volts and putting it onto our power rail. We can now easily connect up ground with ground, so we have a ground connection here. Let's do this. Come on, go in there. Yeah, so now we have a ground connection on our ground plane here, and now we can actually quite easily connect our power rail here with this one here. So now the display should actually have 5 volts, and as ground is exactly beside it, we can connect this one up here as well. So come here, come on, get in there. We need you. We need you there. And yeah, I don't like this breadboard working thingy at all. It's always kind of fiddling around here and fiddly, and yeah. So we should actually have connected that. And essentially, maybe this thing will already power up if we put some power in. So let me just check where I have a corresponding USB cable, which I'm not 100% sure of. Let me check all my different cables here. What do we need? We need a micro USB cable, and of course I do not have a micro USB. Oh, I have a micro USB cable here. Great. So let me just plug this one in here, and let me plug it in here, and maybe, just maybe, the display would be already powering up. No, it is not. Why is it not? We have a ground connection, we have a 5 volts connection. I'm not 100% sure that this one that it just powers up on its own. That we might maybe have something we need to pull low here or stuff like that. We have a reset here. Not 100% sure about this. We have a cable select. Okay, so this isn't working yet, but let's check our library again. So there might be something we need to take care of here. Graphics, base displays, starting point, good image, displays are supported, provide good performance, some this screen to be read, sprites, we fonts. I'm kind of I kind of don't see that there should be some sort of information about on how to wire this thing up. Actually, I know it's an SPI display, so it's not that hard to connect. We need RX, we need TX, we need TX. So we need our MOSI, we need MISO, we need a cable select. But yeah, we have this reset one here, which I, for example, don't actually know what to do with. Maybe we need to pull this lower. high, or don't know. Don't actually know. Do we have some information here? Of course, we will most likely not have information about this here on this side, but you never know. Okay, these are just a lot of pictures from that stuff, and yeah, okay. So let's ask Google. Reset pin. What is it with this reset pin? Appropriate wiring. I've seen a connect reset in two ways. Either share reset, VCC and LED, or connect it to D4. One way correct. You have a number of options. Connect the display reset line, logic 1, and relay on the software command reset that the library uses during init. Connect the reset line to the... okay, that uses a pin as the reset line is only used for the library during the init function, then it is a waste of a pin. Okay, so we need to know if we have to wire up this reset thing or not. Here's a link. Anyone confirm this will fix my problem? But there needs to be a current limiting resistor to 5 volt. Aha, okay, I see. That's why the display didn't power up. So yeah, we actually have this pin here, this where is it, LED pin. It's now I've mirrored it, so you cannot really read it, this one, the LED pin, which actually should be then let me just count the pins. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It should be actually this one, and we need to pull it high, I guess. So this will most likely be the one which tells the background LED to be on. It's a nice thing that we can actually disable and enable it, but for now we want it always on. So we are just putting a current limiting resistor in here, so that there isn't much current flowing through this. I have now the right one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, should be okay. So now let's power this back on again, and let's take a look if the display actually is powering up. Oh, okay, come on here. Ah, okay. I hope you can see this, but now the background illumination of the display is going. So that's a step forward. So let's put this back. So okay. So now I guess we have to connect the data connections and the cable and aka channel select. So let's do this. Actually, pin out. So I actually want to use this side of pins, not this one, because so the left side, because I can better. Let me just show you the hardware overlay here. So because I can actually attach pins here more easily, and those would be underneath, so that I would need to put this one up and put it back, and that's not so great. So let's take a look at this. What can we use here? Actually, we might actually use any of those. I don't actually see any reason why we shouldn't be able to just use any of the I/O pins. yeah, we actually don't need any analog to digital conversion at the moment. We don't have, we can rearrange this later on, but I have to check first if we will be able to somehow set this. And I'm really, I really don't get how this is working here. I know that I have used this library before, and I have the, I'm just thinking that I'm quite sure it was possible to just set the used pins, but this is just initializing here without telling the system what it's actually using for connection, and I don't actually get that, because it does not make any sense. So maybe we should take a look in the header file. Maybe it's documented there. So of course it's not. The built-in fonts, standalone, load fonts. There we have, no, that's color definitions. I'm just looking for some sort of what do we have here? Actually, the width and the height can be given here during construction, but no pins. So maybe we need to really take a look into the source code to see how this is actually defined, because I'm not that sure. Okay, let's take a look. Maybe we can set the, maybe it will just use the SPI. It will, of course, it will use the SPI bus. So I can simply initialize the ESP32 SPI library corresponding to the come on, Arduino. So I'm quite sure this is how this works. I'm initializing the SPI bus library, and I can tell the SPI, if I'm not mistaken, the SPI library which pins it should use. ESP32 Arduino SPI pins. Pinout reference. 3 SPI interfaces there. Which one are which are those? So no, I don't want. I exposed in some ESP development boards. However, these pins are connected to the integrated SPI flash, and so don't use these pins in your project. So we don't want to use GPIO 6 and 11. Okay, I can live with that, I guess. So we might use 7 and 8. By default, the pin mapping for SPI. There we are. So there we are. So let's check out which one is this here. Can I see this actually? 23, 19, 18, 23. Which side is it on? This is... There we have GPIO 23. 19 should be somewhere here. 18, where is 18 is just besides that, and 5 should be on this side as well, I hope. Otherwise this wouldn't make Where is GPIO 5? There it is. Okay, so I guess we can wire this up this way. So yeah, let's do that. Let's wire it up according to this table. There we go. So we need, first of all, we need the cable select, which is this one. And cable select, according to this table, should be GPIO 5. So let's connect this with GPIO 5. GPIO 5. That is this one. So yeah, let's just put this one there and this one there and make a little bit room here. So because there will be more cables. Most likely this will be the way to do it. Yeah, I'm not the perfect one when it comes to putting up those connections and cables. So yeah. So okay, wow, there. A cable just fall to the ground. So the next one would be from this side would be the STI or the MOSI, and MOSI is 23. So I'm never 100% sure with this, as there might be the need to kind of reverse MOSI and MISO. So it's like RX and TX. So this cable is a lot too long for this. So that the RX is the TX on the other side and vice versa. So, but yeah, we will see. This won't be fitting as well. So, okay, then let's do this anyway. So we have 23 here, and we are going. Where are we actually going? The 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's put this one here. Yeah, maybe I will shorten this leads later on, and if we have figured out how this is going to work at all, then I will connect it up a little bit better so that we can have a cleaner layout of it later on, which will make things easier for us. So okay. The next one would be the clock, actually. Where's the clock? Is this the clock? I guess so. Wait, we missed the... No, we connected the cable select. Okay, let's connect the clock. I guess this is the clock. Which is directly the side of it. So let's just connect this one to, what should the clock be? GPIO 18. 18. Where is 18? 19, 18. There is GPIO 18 just besides this one. Yeah, this is not great work at all, but I will clean this up once we figured out how this is going to work. So yeah, what's the next one? That would be MISO. So MISO is just besides the LED, so it is here. It is here. Now come on. So yeah, and MISO should be, which pin should MISO be? 19 in this configuration. So where is GPIO 19? It is there, just in the same region as, yeah. Looks good, I guess. This one really really making a connection. Yeah, I really need to. I really need to clean this up. So, okay. Hopefully we have now connected all the pins we need. So we could actually start by creating a new. There we go. Creating a new. What? Where did this one go now? Creating a new. Yeah, let me make this a lot bigger. Otherwise you might not be able to see anything. So okay, let's get started by going to the platform IO home and create a new project. And we will call this one, how we will call it? Let's call it how do we call it? I have no idea how actually I should call this one. Let's call it, we can call it stream thingy for now. So yeah, boards. We actually want most likely to have the VMOS D1. It's just an ESP32 development board. They should be there. And we want to use the Arduino framework actually, because we have a lot less problems with libraries then. So yeah, okay, we need to download the framework. I guess I could have done that before, but yeah. Let's download this one then. It's currently downloading with about 4 megabytes a second. Can't take. Hopefully it won't be this much time. I've actually the system I'm currently doing this on is quite new, so I never actually installed this one there. So yeah, okay, so now we have a simple platform IO project here. Let's check. We have an empty setup and empty loop. That's absolutely okay for now. But let's just put this thing on here. You can't see what I'm doing again. So let me put overlay here. I've just connected the Arduino and the ESP, not the Arduino, and now I'm just trying to upload this. Let's check if it can be compiled. So if the library is there and if an upload can be done. Okay, that doesn't look so great, but USB serial 0001 doesn't look like the doesn't actually look like okay, so that did it. Actually it was named USB serial 0001. Okay, so of course this sketch won't do anything now because we have no code in here. But what we can do now is we can go to libraries and we can search for ESPI. I guess that's what it was called, wasn't it? What was it called? TFT ESPI. Okay, TFT ESPI. There it is. And now we add this to the project. Select the project, stream thingy, add. Perfect. So now we have this there. So now we can, isn't there actually a simple example we could use to just, okay, I never actually find any usable examples within this browser there. So let's just go here and let's take one of the examples here, and let me quickly change this and move the hardware overlay here, somewhere here or here, as nobody is currently in chat anyways. You can see better and more of the screen. So yeah, let's check this one, and for example this one, we took a look into this, and yeah, let's just try and copy all of this here. Let's put this here, and yeah, I'm not sure this will work yet, because actually I don't see why there is no initialization regarding the TFT, the size of the TFT. I'm not sure if can it talk to the controller and find out what size the TFT or the display is actually? Okay, we will see. Or I will just upload this one and then we will have a look if it's displaying anything at all. Okay, it's not compiling. Great. Error, cube was not declared in the scope. Okay, what's wrong with this one here? Where was it? 81 cube. That's most likely because, yeah. Okay, that's most likely because the yeah, the order is different. Platform IO, that's something you need to always kind of change. It's like platform IO pre-declare functions. There is a compile flag or something like that. Order of functions, there it is, and but I never actually know. This is why forward declarations, yes, and yeah, I remember. It's not a compiler flag. I've not developed C and C++ for too long, but C++ can do something like that. No, I've always a forward declarations file. Okay, so the problem, I guess, which we have here is, let me just put this thing where we need to kind of simply put all of this drawing code before the other functions so that the system sees it. Or we could create a forward declaration of that stuff, which would likely be easier. Okay, let's do that. Let's just forward declare all this shit, and then sorry, and then this should work. So we need this one, and where's the next one? We need this one. And then we have process line. I should have looked for a simpler example, I guess, but yeah. There's our cube function. And I guess cube was the last one, was it? Most likely, yeah. So let's now try and recompile this. Now it should work because we have the forward declarations and the compiler actually knows what we are talking about if we're calling such a function. Okay, it's uploading, or it's trying. Actually, let me reset this one so that it actually sees it. Okay, not working. Kind of strange. Worked before. That's kind of not very great. Yeah, okay, I guess that's okay because it doesn't see the port there, but there we go. So just a connection issue, I guess. So yeah, let's check if there is anything happening. There is nothing happening on the display. Let's check if we can get some serial monitor output. Is there anything on the serial monitor if we reset this? No. Most likely because we haven't initialized serial anywhere. So maybe we should do this, and then we should output some data just to make sure that that this one is working actually. Come on. Okay, let's do this 9600 baud. And we, for example, are reading the TFT information here. We could serial print line height. Serial print line H. So now we have the width. Just to see if this is actually working, which it seems to me isn't, but yeah, let's take a look. Let's reset this again so that it finds the that's kind of strange. Why isn't it registering? Okay. So, okay, we are getting information that there is a height of 320 and a width of 240, but I'm not sure that this is actually coming from the TFT itself. So that's kind of okay. Let's for now let's. Is it running the loop? Is it actually? Let me take a look here. Setup loop. Okay, so let's just serial print line loop or image was drawn rendered. It's not a good sign if I'm starting to think about what kind of debug messages I want to write. Okay, I need to reset this one. That's kind of strange. Why is it not? It's not. Yeah, of course there occurred an error because I resetted it while it was writing. That can't work. It seems to me that it is trying to connect every time, but it's not. Why is it not working? What is happening there? Usually it should be just a button press and it should connect easily. Okay, there we are. So let's just, okay, so at least we now know that it is inside the loop. So we are not sure if it can't talk with the display or what's happening there, but it is inside the loop. So let's power this thing off and let's take a look at this one. It might be that's what I initially said was that this MISO and MOSI need to be reversed. So let's take a look at this. So we have this one here, which is 1, 2, 3, 4, 5, 6. It is this one, 1, 2, 3, 4, 5, 6, which we should then exchange with this one here. So let's put this one over here and let's take this one and put it over there. 1, 2, 3, 4, 5, 6. Yeah, that might do the trick already. Let's check this connection. Doesn't look like it's really in. So okay, now let's take a look at this. Maybe it's not working. No, doesn't seem like it. So this wasn't the problem. Yeah. Okay, so why is this not actually working? Maybe let's check if we have something like TFT SPI wiring up. There should actually be some more information about how to wire this thing up. So let's take a look. TFT working or a little VGL. However, I'm making head rate, getting settlement to work. Okay. TFT screen with my ESP. Okay. That's not good. So we are actually using VSPI, if I remember correctly. What did we have here? I think I've used, no, I think I've used, no. Too bad. I guess yeah, great. Not great, not great. It was here. We are using VSPI, so set up VSPI ESP32. Yeah, we can use them simultaneously, but I want actually to, in order to use the, so let's check something here. Can we okay, it seems to me that either we are not using the right pins or there is a problem with our connection or our configuration. So yeah, I will make a short break here because I need to get some more water. and I will be right back in about 5 minutes, I guess.